Good morning, students. Myself, Dr. S. Devikala, Associate Professor in the Department of Chemistry, SRM Institute of Science and Technology. In today's class, let us see about the polarizability and the Fajans rule. So, the term polarizability, it refers to the tendency of matter when subjected to an electric field to acquire an electric dipole moment which is proportional to that applied field. Magnetic polarizability, it refers to the tendency for a magnetic dipole moment to appear in proportion to an external magnetic field. Electric and magnetic polarizabilities determine the dynamic response of bound systems such as a molecule or crystal to external field and provide insight into a molecule's internal structure. Polarizability should not be confused with the intrinsic magnetic or electric dipole moment of an atom, molecule, or bulk substance. These do not depend on the presence of external field. So, if you have cation and anion, when these two are held together by closer means, then the cation will attract the electrons of anion. As a result, this leads to the distortion of the size of anion. The distortion only, it is known as polarization. So, the ability to attract the electrons of anions towards itself by the positively charged cation, that is called as distortion or polarization. So neutral nonpolar species have spherically symmetric arrangements of electrons in their electron clouds. When in the presence of an electric field, their electron cloud will be started. That's what I told you. The created distortion of the electron cloud causes originally nonpolar molecule or atom to acquire a dipole moment. This induced dipole moment is related to polarizability of the molecule or atom. So you can see this is your cation and anion. So the electrons of anion are being attracted by the cation. So this leads to distortion. Such distortion due to polarizability within a chemical bond, which in turn increases the covalent character. So by considering the concept of polarizability, Fajans has formulated certain rules in order to predict the type of polarization. So, in case of Fajans rule, which was formulated by Casimir's Fajans, are used to predict whether a chemical bond will be covalent or ionic and depend on the charge and the cation and the relative sizes of the cation and anion. So, factors that affect polarizability, that is, polarization will be increased by high charge and small size of cation. Ionic potential. So ionic potential, it is nothing but it is a measure of charge to radius ratio, that is polarizing power. The ability that describe the amount of polarization, that is called as polarizing power. High charge and large size of anion. If the anion is large, then more electrons will be there so that the cation can attract the electrons towards itself. The polarizability of an anion is related to the deformability of its electron cloud. So polarizing power is more for smaller cation. Smaller the cation, polarizing power is also low. Large cations have less polarizing power. So smaller anions are less polarizable, whereas large anions are more polarizable. So low charge, covalent nature increases. So small cation, large anion and large charge. These three are the deciding factors for amount of polarization. So smaller the cation, the high polarizing power stems from the greater concentration of positive charge on a small area. This explains why lithium bromide is more covalent than KBr. Large anion, the high polarizability stems from the larger size where the outer electrons are more loosely held and can be more easily distorted by the cation. So this explains why the common halides iodides are the most covalent in nature. Then the third one, large charges. As the charge on an ion increases, the electrostatic attractions of cation for the outer electrons of the anion increases, resulting in the degree of covalent bond formation increasing. So when the cation is same, larger the size of anion, higher would be the covalent character. So you can see the trend over here. NaF less than NaCl less than NaBr less than NaI. When the anion is same, the smaller is the size of the cation, higher is the covalency. In that case, cesium fluoride, rubidium fluoride, potassium fluoride, sodium fluoride, and lithium fluoride. So we have to find out which is having more covalent character along with the compound. So among all the cations, that is you have sodium, magnesium, aluminum. So among the three, Al3 plus has smaller size and greater charge, hence it has greater polarizing power. Whenever the size is small, polarizing power is more, inversely proportional. Among anions, iodide is larger and hence can be polarized easily. Hence the combination of these two ions, Al3 plus and I minus, results in more covalent nature. So I'll repeat, smaller the size of cation, anion should be larger. Then only the power of polarization is more or the polarizing power is high. One more example, among LiCl, RgCl, BeCl2 and MgCl2, the compounds with the greatest and the least ionic character, which is least, rubidium chloride and beryllium chloride. So some more information regarding the Fajans rule. When the cations have octet configuration, that is completely filled configuration, or inert gas configuration, we know very well inert gas configuration means completely filled, NH2, NP6. In their outermost shell, the effective nuclear charge properly shielded by the inner s and p electrons. Hence, their polarizing power is less than expected. Therefore, the ionic compound with these cations have less covalent character. Whereas, nuclear attraction is not properly shielded when there are electrons in the d sublevel. Therefore, the cations with pseudo-octet configuration, that is NS2, NP6, ND10, possess high polarizing power. Therefore, the main group metal compounds are more ionic, whereas the transition metal compounds are more covalent. For example, for our understanding, calcium chloride is more ionic due to the inert configuration, that is 3s2, 3p6 in case of C, calcium 2 plus ion, whereas zinc chloride is more covalent due to pseudo inert gas configuration in the Zn2 plus ion, that is 3s2, 3p6, 3d10. One more question in order to make it clear. Even though the crystal radii of both A plus and Ag plus are almost the same, the melting point of AgCl is only 455 degree, whereas KCl is 776. The best explanation, AgCl has more covalent character than KCl due to greater polarizing power of silver ion. So overall, the concluding statement will be smaller the size of cation and larger the size of anion, then the power of polarization or the polarizing power is high. Only this point we have to understand from the Fajans rule. Thank you. Thank you all. Let us see in the next class.